Good afternoon, all of you. Am I audible?
Yes, ma'am.
Okay. Screen is visible to you?
Yes, ma'am.
Okay. Okay. So let us start with the lecture. In the previous lecture, we have seen the need of homogeneous coordinate system. So in homogeneous coordinate system, a 2 by 2 array is converted into 3 by 3 by inserting one row and one column, where the element h is considered as overall scaling factor, and or it is also called as homogeneous coordinate factor. And there is a relation between the actual coordinate and the homogeneous coordinate system is shown here. That is nothing but if x is the actual coordinate, then it is xh by h, where xh is the homogeneous coordinate x value and h is the overall scaling factor. Similarly, for y also, the same formula is there, that is yh upon h. And it can be also written as xh is nothing but x into h. So I will be replacing xh by h into x, yh by y into h, and h as it is. So for a single point, we can have multiple representations in homogeneous coordinate system, or we can say infinite number of equivalent representations, right? And that is the convenient choice we are considering is x comma y comma 1, where 1 is the homogeneous coordinate system, coordinate factor. Then we have seen the combined transformations. In the combined transformation, the order of the operation is very important. And there are two ways how we can perform the combined transformation. One is uh, the original object, we can apply transformation number 1. Then it will give me p double dash. Then on that p double, that is, sorry, the original value is, original matrix is P. On that, I am applying the first transformation. It will give me P dash. Then on P dash, I will apply second transformation. I will get P double dash, and so on. So every time the original matrix is changing in the first method. That can be replaced by T equal to the combined transformation, that is nothing but the T total is T1 into T2 into T3. Three transformations are made. Then we can have the T total as multiplication of all those three T matrices. And then finally, we can get the ultimate result by just multiplying the T total with the original matrix. So these two methods we have already studied. Out of that, the second method is convenient because it is a two-step process. Then we have seen the example also in case of order of the operation. So here the matrix multiplication is non-commutative, and that's why we have to follow the order of the operation in order to get the accurate result. If we change the order, then we will be getting the different results. So this is seen with this example, that if I am changing the order of the matrix multiplication, see, this is your first matrix, second, and followed by third. Is this the same T matrices I am using over here? First, this one, and this second, I am interchanging this order, and the third as it is. Then I am getting the different result. So if you want to get the accurate result, you have to stick to the order of the operations compulsory. Then next is we have seen rotation about arbitrary point in space. So till now rotation we have studied with respect to origin. Now this is the arbitrary point P, and we need to follow the rotation about that arbitrary point. So for that, what we have to do is shift that point to origin. Then once it is um, coincident on origin, then carry out the rotation. And then that rotated figure you have to translate back to its original position. So this way, we are going to follow these steps in order to get the rotation about arbitrary point. Okay, so the three steps are there. So here we are using the combined transformation. First translation with minus px minus py, then carrying out the rotation, and then translating back with px comma py to its original location. So this is how the rotation about arbitrary point is carried out. So we have seen this much part. So these are the T matrices for the same. That is the translation with px py value, then rotation, and then translation inverse. So this is how you are calculating the T total. And once the T total is with you, simply you have to multiply it with the P matrix in order to get the resultant value. Okay. So let us solve this problem. So the problem given is, here it is not scaling, here it is rotation about arbitrary point only. So it is a rotation about arbitrary point P, where the px py values are given. So I will have the example. Okay. Okay. So one simple example we will take for your understanding. This is a triangle. Okay. So let us say this is 5. This is 10. This is 15. And this is, let us say, 15 again. Okay. Now this is a triangle given, and you have to perform the rotation of the triangle about this point A. This is point A, this is point B, and this is point C. Okay. So what is the question? Triangle ABC is given, and you have to carry out the rotation about this rotation of this triangle about point A by 90 degree. By 90 degree in anti-clockwise direction. Okay. So what is the theta? Angle of rotation is 90 degree. Angle of rotation is 90 degree. Then can you tell me P matrix? P is your original matrix. Remember, you have to use homogeneous coordinate system because here the translation is required to carry out. And that's why every two-dimensional 2x2 matrix should be converted into 3x3. So the points A. So the point A having coordinates. Oh, I have forgotten to write. I have forgotten to write this. This is 5. Let us see. Okay. So coordinate A is 5, 5 and overall scaling factor 1 so that xy will remain as it is. Then point B is 15, 5 and 1 as it is. And point C is 10, 15 and H1. So this is your P matrix. Now what about the T matrix? So it is the example of combined transformation, right? Because we need to carry out the rotation about point A. Whether any specific T matrix is available to you? No. The rotation matrix available to us is with respect to origin. The T matrix which we are having is with respect to this origin, not this arbitrary point A. So what is the method we have learned in the previous lecture? We are going to shift this point to the origin. We are going to shift this point to the origin. So for that shifting, what will be the T matrix? So I will write here. Translation of A to 0, 0. Now A is having coordinates 5, 5. That I want to make 0, 0. Means what will be the translation values? Along x-axis, I have to move towards left. This is your A point. And I want it to be 0. So A should be moved towards left so that its x parameter will become 0. So the T matrix will be T matrix is 1, 0 and Tx. So what is Tx? Tx is -5. Then 0, 1, Ty. Ty is what? Ty is also -5 and 0, 0, 1. So I am taking the transpose of the T matrix. Remember that. So this is your T translation. So first step is we are shifting the point A to the origin. Next, once it is coinciding, now I am having the T matrix of the rotation. So T matrix of rotation is cos of theta minus sin theta. Anticlockwise rotation is there. Then sin theta cos theta. This element is 1, the remaining all are 0. So you are having this T rotation. Because now the rotation is available with respect to origin because A and origin are coinciding. The next, once this rotation is over, what is our next task? As we have shifted this A downwards, we have to shift it back to its original location. So shifting it to its original location is nothing but the T translation inverse. So I will have T translation inverse. That means by 5, 5 amount towards left and down we have shifted. Now we have to shift 5 units up and 5 units right so that A will come to its original point. And that is done with this T matrix 1, 0 minus 5 will be converted into plus 5 because we have to make it to lie on the same location where it was earlier, and 0, 0, 1. So this is your T total. So what is T total? It is T translation into T rotation into T inverse translation. So here T translation, T rotation, and T inverse translation are the 3 T matrices. So I will replace here cos theta. Theta is 90 degree. So cos theta, cos of 90 is 0. Then sine of 90 is 1. So minus 1. Then sine of theta is 1 and cos theta is 0. So this is the T total matrix. Now perform the multiplication. So after matrix multiplication, what is the result? So I will write multiplication of these two here. These two multiplication result I will be writing here, and this T inverse as it is. So 1 into 0, 0, 0. So here I will have 0 itself. Then first row, second column, that is minus 1, 0, 0. So minus 1. Then 1, 0, and 1 into minus 5 is minus 5. Okay. Then the second row, first column. So 0, 1, 1 as it is. Then this row and second column, 0, 0, 0. And this row and third column is minus 5. Then comes third row, first column, all zeros. Third row, second column, all zeros. And third row, third column, 1. Now carry out multiplication between these two. So 0 into 1, 0. Here also 0, here also 0. So first value is 0. Then 0 into this, 0. Then minus 1. Then this row and third column, that is 0, minus 5, minus 5, that is minus 10. Then 105 with this 1 into 1, only 1 here, remaining all things 0. Then 1, 0, the second row and second column, all zeros. The second row and third column is 5, minus 5. So it is 0. Then the third row, first column 0. Third row, second column is also 0. And third row, third column is 1. Okay, so this is your T total. And now you have to multiply P with this T total to get the final answer. So I will be multiplying this with so here also we need to take the transpose because we are writing XYZ in this manner. So here transpose I will take 5, 5, 1, then 15, 5, 1, and then 10, 15, 1. When I multiply this with this T matrix, 0, minus 1, minus 10. then 5, 5, 15. Oh, sorry, 1, 0, 0, this T matrix, and 0, 0, 1. Now carry out this multiplication, first row, first column. That is 5 into 0, 15 into 1, 50. Then first row, second column. So 5, that is minus 5 only. Then wait for a while. If something is wrong in calculation you have done in your notebook, okay, here there is no need of taking this transpose actually. The direct multiplication P into this is your T total. So if T matrix is there, then only transpose we are taking. This matrix into this one, so that we can get the ultimate result. So this P matrix into this T total, P into T total, that we will go for. So 5, this first row and first column. So 5 into 0, then 5 into 1 and 1 into 0. So first variable is 5, or first parameter. Then second row, first column, first row, second column, sorry. So 5, 5, 1 into this second column. 5 into minus 1 becomes minus 5, remaining 2 are 0, 0. So here minus 5. Then 1 as it is. No, something has become. Wait. We will have that diagram again. Instead of that paper, I will use whiteboard. Okay. Okay, so we will take the same coordinates. A point is 5, 5, 1. B is 10, 5, 1. And C coordinate is, or here 15 was there, no? So 15, 5, 1 was there. 25, 10, 15, 1. This is our original P matrix. Then shifting this A to origin. So for that, we will take the T translation. So translation for shifting A to the origin. So A is having coordinate 5, 5. So I will write without taking the transpose, I will write here. So our T matrix is 1, 0, 0, 0, 1, 0, and Tx, Ty, and 1. So Tx, Ty distances are towards left and towards bottom, and that's why -5, -5 it will be. This is your T translation, followed by T rotation. So what is the T matrix for the rotation? Here you are having the cos theta. So cos of 90, then sine of 90, 0, then minus sine 90, cos 90, 0, and 0, 0, 1. This is your T rotation. And again, T translation inverse is shifting of this point to its original location A. So 1, 0, 0, 0, 1, 0. And now I will have, instead of -5, I will have +5, because from 0, 0, it should move to 5, 5. That means 5 units right, 5 units up. So I will have here 5, 5, 1. Now perform the multiplication. So T total is this. Cos 90 is 0. Sin 90 is -1. So here cos 90, 0, sin 90, minus sin 90. So here it's 0, 1, 0, and -1, 0, 0, and so on. So perform this multiplication. 1 into 0, 0, 0, 0. Then first row, second column, 1. First row, third column, 0. Then second row, first column is -1. Second row, second column is 0. And second row, third column is also 0. Then third row, first column. So -5 into 0, this minus minus becomes plus. So it will be 5 and 0. Then this row and second column is -5. Remaining all things as it is. Okay. And 1 into 1 last element. So I will have the third matrix as so. Now I will perform the multiplication again, and this will give you the T total value. So 0, 1, 0 into this. So it will become 0. This into second. So 1 into 1, only 1 here it will be. This into third is 0. Then second row, first column is -1. second row, second column is 0, and second row, third column is also 0. The third row, first column is 5, 0, and 5 here. So 5 plus 5, I will get 10. Then this row, second column, 5 minus 5 is 0, plus 5 is 5. And next, third row, third column, so 0, 0, and 1 as it is. So this is your T total. And now when I multiply it with T total, so that is 0, P into T total is 0, 1, 0, minus 1, 0, 0, and 10, 5, 1. So I will have P into T total as my P dash. That is the result. So perform the multiplication. First row, first column, 0, minus 5, plus 10. So 5 into 0 is 0. Here is minus 5, and 10. Minus 5 plus 10 is plus 5. Then second row, second column is 5, 0, and 5. So you will have 5 into 1, 5, 0, and 5. That is 10. Next is this row, third column is 1. The second row, first column. So 15 minus 5 plus 10. So minus 5 plus 10 is 5 again. Then second row, second column is 15 plus 5, that is 20. Then 1. Then 10 into 0, 0. The minus 15 plus 10. So it is minus 5. And minus 5. Then this row, second column is 10, 0, and 5. So here it is 15. And last row, last column. Okay, so these are the coordinates after rotation. So we can have 5, 10. This is your 5. This is 5. This is 15. This is 10. And here it is 5. And here it is 15. Okay. So this 5, 10. So 5, 10 is this point. Then 5, 20. So 5, this is 15, this is 20. So 5, 20 is this point. And then minus 5, 15. So this is your 15, and minus 5 is this side. So here somewhere. That means ultimately I am going to get this triangle like this. So the horizontal side has become vertical, and that's why the angle of rotation is 90 degree. And this is the same value, that is 15 is kept constant, which is your y value here. X is changing, and that is how the rotation is carried out with arbitrary point. Okay, so angle of rotation is 90 degree. So the side which was horizontal before, that has become vertical in anti-clockwise manner, and we have got the rotation in the anti-clockwise fashion with 90 degree, so that this horizontal side has become vertical. The angle between this horizontal and vertical is 90 degree, and that's why the angle between these two is also 90. Okay. Getting it now?
Yes, ma'am.
Yes. So we are having the rotation about arbitrary point, and that is what the rotation is carried out like this, and we are going to get the output with combined transformation. So always remember the order of the operation is very important in combined transformation. You have to follow first translation, followed by rotation, followed by translation inverse. The same way you have to go for, because matrix multiplication is a non-commutative nature. Okay. So we have studied this point, that is how to carry out the rotation about arbitrary point. Now the next point is reflection about arbitrary line, or reflection about arbitrary point in space. So we are going to carry out the reflection about any arbitrary point. It means ultimately the line should be passing through it. Now tell me, how many types of reflection we have studied? Reflection. Yes. Reflection about which axis we have studied already? Reflection is a mirror image. So can anyone tell?
X-axis, ma'am.
Okay. So we have studied the reflection in 4 cases: reflection about x-axis, reflection about y, reflection about y equal to x, and reflection about y equal to minus x. Right? So we have studied these 4 kinds of reflection, and we have seen the T matrix. Now, what is the common thing in all those 4 axes? What is the common thing? The origin, because every axis is passing through origin. So I say like this: reflection about any axis is carried out, then that axis should pass through origin. म्हणजे मी कोणत्याही ऍक्सिस बरोबर रिफ्लेक्शन काढू शकते, but that axis has to pass through origin. That is the condition. Okay. Now my question is, I am having one axis like this. I am having one axis like this. I will draw it more properly. Okay. I will have this axis. Now, can I get the reflection about this axis? आतापर्यंत आपण काय बघत होतो, इथे एक ट्रायंगल काढला, त्या ट्रायंगलचं एक्स ऍक्सिस बरोबर रिफ्लेक्शन घेतलं ते इथे येईल कुठेतरी. जर याच ट्रायंगलचं वाय बरोबर रिफ्लेक्शन घेतलं तर ते इकडे येईल. जर याच ट्रायंगलचं वाय इक्वल टू एक्स बरोबर घेतलं तर ते इथे येईल रिफ्लेक्शन. अँड फॉर वाय इक्वल टू मायनस एक्स घेतलं तर ते इथे कुठेतरी येईल. बरोबर. So we have seen all those 4 conditions, but now what I want the reflection of the triangle with respect to this line, black line. Getting the difference? I want the reflection about this any arbitrary line. So how to carry it out? So first thing is, our basic condition for reflection is the axis should pass through origin. जर axis तो origin मधून pass होत असेल, then we can apply the reflection matrix on it. So what I have to do is, I have to shift this axis downwards so that it will pass through the origin. मला आता रिफ्लेक्शन या ब्लॅक ऍक्सिस थ्रू हवंय. I want the reflection with respect to this black axis. So what modification I can go for? I will shift this downwards. So by this much amount, this red vertical line is there. So with this much amount, I am going to shift this downwards, which is called as the intercept, y-intercept of the line. Right? Because the line is crossing the y-axis at this point, and that's why this distance between origin and that intercept is called as y-intercept. Okay, so I will shift this line down by y-intercept amount. Here the intercept is equal to 2 असेल. Consider kara this intercept is equal to 2. So I will shift this line by 2 units downwards. So shifting this line will give me somewhat like this, the parallel line of this, right? 2 unit ने मी त्याला downward shift केलं. Now that line is passing through the origin. आता ती line काय करतीये? Origin मधून pass होतीये. But still, I'm not able to write the T matrix for this line because it still एक arbitrary line है, which is neither your x-axis nor your y equal to x, neither y equal to x or y equal to minus x. यापैकी ही line नाहीच आहे कोणती पण अजून. So what I have to do is I have to rotate this line with this angle so that it will coincide on x now. What operations I have done? I have translated that line so that it will pass through origin. Now it is passing through origin, but it is not coinciding on any of the axes. And that's why I will rotate this so that it will coincide on any of the coordinate axis. X axis वर असेल किंवा y axis वर असेल, मी कुठल्याही direction त्याला rotate करू शकते. So second step is rotation. मग rotation झाल्यानंतर काय होईल? Now the red line and black lines are coinciding on each other. That is, this x-axis and the axis of reflection are lying on each other. They are coinciding. मग मला माहिती आता T matrix with respect to x-axis काय? I know the T matrix for reflection along x-axis. So the next step is reflection carry out. Right? So first step was translating the line so that it will pass through the origin. That is the translate operation. Second is rotate the line so that it will coincide on any of the coordinate axis. That is rotation. And third is, now as it is coinciding on the coordinate axis, you can carry out the reflection. So that is your third number step. And once the reflection is done, our purpose is over. So you have to translate the line back to its original position. So ती line होती तिथे तुम्हाला परत shift करायची आहे. And that's why whatever the rotation you have carried out, the reverse rotation you have to go for. That is called as reverse the rotation. And then the translation downwards you have done, then reverse the translation also. Translate the line back to its original position. Getting it? All of you?
Yes, ma'am.
Boys side?
Yes, ma'am.
Okay. So these are the 5 steps for the reflection about any arbitrary line if it is not passing through the origin. The thing is, if the line pass through origin, जर ती already origin मधून pass होत असेल तर काय करावं लागेल तुम्हाला? फक्त रोटेट करून कोइन्साइड करावी लागेल, रिफ्लेक्शन कॅरी आउट करावं लागेल आणि परत रोटेट इनवर्स करावं लागेल. And that is why we need only 3 steps. First आणि fifth ची गरज नाही, because that line is already passing through the origin. Simply rotate, reflect and reverse rotate. Getting it? Yes?
Yes, ma'am.
Okay. So that is how the reflection through arbitrary line is carried out by making use of combined transformations. So that is written in terms of matrix form. The steps, 5 steps that we have discussed. So step 1 is the translate the line so that the line passes through origin. That is called as TR, that is translation matrix. Then second step is rotate the line until the line is coincident with the in any coordinate axis, either x-axis or y-axis, like that. So rotate the line. That is carried out with RO. Then the third is reflect it. So actual reflection is carried out here. And once the reflection is over, perform the reverse transformation, reverse rotation, reverse translation. So this is the T matrix, or we can say T total. So we are having this particular example. Reflect a point 5, 9 about a line y equal to x plus 5. So what you have to do is, I will show you the actual working. The calculation part I will not go in detail, but only I will show you this thing. That is A 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 5, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 1, 2, 3, 4, 5. So 5, 9 point is somewhere over here. Okay. So this is your point A with 5, 9. Now what I have to do is, I have to reflect this A about a line y equal to x plus 5. Y equal to x plus 5. Can you tell me the coordinates? Any two points which will lie on this line, so that we can complete the line. Consider x is equal to 0. If I put x is equal to 0, what is the value of y? Y equal to 5. All of you agree with this? I will put x is equal to 0, then y will become 5. So first point on the line that I will get is x0 and y equal to 5. So this point. 1, 2, 3, 4, 5. Okay. 5, 0, 5. So x is 0, y has become 5. X is equal to 1, y becomes 6. So when x is equal to 1, y will become 6. This point. Then when x is equal to 4, y will become 9. So 4, 9. So 4 and 9. somewhere over here. Okay. So it is the line of our choice, any arbitrary line. Okay. Suppose x is equal to 5, then y will be 10. No? Okay. So we will take this also. Y will be equal to 10. Okay. This is a line. Now I want to reflect this point A through this arbitrary line y equal to x plus 5. So how you will proceed? First is this line, whether it is passing through the origin. Yes.
No, ma'am.
Yeah, it is not passing through the origin. It has the intercept equal to 5 because x value is 0, y equal to 5. So this has intercept is equal to 5. So I will shift this line downwards so that it will pass through origin now. So for that, what will be the T matrix? T matrix will be 1 0 0 0 1 0. This is the translation matrix. I need to translate the line so that it will pass through origin. Now there is no need to change x because x is already 0 and y is 5. Y value 5. X axis, y axis वर x value already 0. So there is no change in the x required, but y need to be moved down by 5 units. Okay, so this is your T translation matrix. So first step, T translation. Then second step, with this translation, now the line will pass through origin. आता ती line इथून pass होती origin मधून. 5 units downwards, I have moved that line. 5 units down. Okay. Next, you need to carry out this rotation. Okay, you need to carry out this rotation. Then what will be the angle of rotation? How you are going to find out the angle of the rotation? Yes. Can you tell me how you are going to find the angle of rotation? This line is now moving from the origin, but or passing through the origin, but it is not coinciding on the x-axis. मग ते एक्स ऍक्सिस वर कोइन्साइड होण्यासाठी काय करावं लागेल मला एवढ्या अँगलनी रोटेट करावं लागेल पण हा अँगल अननोन आहे दिस अँगल वी आर नॉट नोईंग yes so I will have this point of the line which is now this point is 0, 0 is 1 point and I am moving this downwards. In that I am not changing the x parameter. I am changing only y with -5 value. So for any point where x is equal to 2, suppose x is equal to 2 here. So what is corresponding y value that we will find out. What is corresponding y value? When x value is equal to 2, earlier y value was what? x व्हॅल्यू जेव्हा 2 होती तेव्हा y ची व्हॅल्यू काय होती 7 होती. राईट, when x was 2 plus 5 y ची व्हॅल्यू 7 होती. पण आता y आपण 5 ने कमी केलाय. सो नवीन y ची व्हॅल्यू काय असणार आहे 2. सो x जेव्हा 2 आहे तेव्हा y ची व्हॅल्यू पण 2 आहे. तसंच x ची व्हॅल्यू जेव्हा 3 असेल तेव्हा काय होईल, x 3 पुट करून आपल्याला मिळत होता y अर्लियर 8, पण त्याच्यातून आपण 5 मायनस केलंय. सो x ची व्हॅल्यू 3 असताना y ची पण व्हॅल्यू 3च आहे. That means we are on the line y equal to x. We are on the line y equal to x. मग आपल्याकडे ऑलरेडी रिफ्लेक्शन मॅट्रिक्स आहे y equal to x लाईनचा. What is that reflection matrix? For y equal to x line, I am having this reflection matrix. X becomes y and y becomes x. So that is your ultimate reflection matrix. मग आपल्याला रोटेशन कॅरी आउट करायची गरजच नाही पडली, कारण ऑलरेडी दिस y equal to x axis चा T matrix I was having with me. त्याचा रिफ्लेक्शन मॅट्रिक्स ऑलरेडी माझ्याकडे होता. जर in case this is not the line of y equal, this is not the y equal to x line, then we have to go for tan of y by x, because slope is getting determined and with slope theta can be calculated. Tan theta म्हणजेच slope असतो. So once we get the slope by y by x, आता पण बघा तुम्ही y by x केलं तर काय होतंय 2/2 म्हणजे 1. tan theta is equal to 1 आहे, म्हणजे थीटा काय आहे 45 डिग्री. 45 डिग्री म्हणजेच y equal to x लाईन. कळतंय? जर इथे हे इक्वल नसले असते, y ची व्हॅल्यू समजा 3 असली असती, इथे y ची व्हॅल्यू 4 असली असती, तर काय झालं असतं 3/2 करावं लागलं असतं. y by x is 3/2 and that 3/2 value is assigned to the tan theta. आणि मग थीटा व्हॅल्यू tan इनवर्स 3/2 करून तुम्हाला काहीतरी व्हॅल्यू मिळाली असती. तेवढ्या अँगलनी you have to rotate it. So here it will not be directly the reflection matrix. Here it will be the rotation with respect to theta, and then you have to carry out the reflection about x-axis. Getting it? Yes, students? Getting it? Or shall I repeat it?
Yes, ma'am.
Boys side?
Yes, ma'am.
Getting? Okay.
Yes, ma'am.
Right, thank you. So that is how you have to do translation first, then a rotation if required. Here rotation is not required because already the coordinate axis we are getting after shifting it down. So y equal to x axis is only available. So directly I can carry out the reflection. And then again T translation inverse. So inverse translation is the third step you have to take. Okay, so this is how the reflection about arbitrary line is carried out. So that is about all 2D transformations are over. Now we are going to switch to 3D transformations. So it is just the comparison of 2D and 3D now. So all of you are aware about the 2D T matrices. Here the same things we have to apply on 3D. So in 3D transformations, the three coordinates are considered, that is x, y, and z. So three elements or 3 coordinates you have to take care. Earlier we were having only xy coordinates. Here z is also coming into picture. Okay, so 3D point homogeneous coordinate. In that homogeneous coordinate system, it is represented as xyz1. Suppose if this overall scaling factor is 2, then what will be these 3 values? Overall scaling factor जर 2 असेल तर इथे काय असेल 2x 2y 2z असेल. The whole array or the whole matrix will be getting multiplied by the overall scaling factor. So this is how the point is represented. So point is represented either in 3 rows 1 column or 1 row and 3 columns. So here it is x, y, z like this. So 2 representations are there. You can apply any one. And 3D homogeneous coordinate also we can write in 2 ways. Either the 4 rows and 1 column, or I can have 1 row and 4 columns. Okay, so that is the representation of 3-dimensional point. So 3D coordinate system is represented with right hand as shown here in the figure. When I am stretching my thumb, forefinger and middle finger, which are making 90 degree with each other. You can see the angle between every 2 axes is 90 degree. This and in the direction which is moving away, right? So here is the 3 fingers which are at 90 degree to each other. Then it represents, thumb represent x-axis, the forefinger represents y-axis, and the middle finger will represent your z-axis. So this is for right hand. For left hand, similarly, x, y, z. Here, the direction of z is reverse. This z is pointing towards the user. This z is pointing away from the user. That is the 3D coordinate system using left hand and right hand. Now, the T matrix, we will see the 2-dimensional T matrix. If I will be writing the 2-dimensional T matrix, then A, B, C, D. This is the translation along x-axis, translation along y-axis, and overall scaling factor. And these 2 elements are always 0 because they are used for projection purpose. Now here, which elements are responsible for translation in this T matrix? Which elements are responsible for translation?
Tx and ty.
Right, Tx and Ty. Similarly, in 3D, you are having Tx, Ty, Tz. So the T matrix for 3D translation is Tx, Ty, and Tz because we have to concentrate on the Z value also now because the 3rd dimension is depth, Z value. Then, which elements in the 2-dimensional is responsible for scaling?
Sx and sy, ma'am.
Sx and Sy that are written here as A and D, diagonal elements. बरोबर आहे, आपण इथे 2 आणि 2 लिहित होतो मल्टिप्लाय करण्यासाठी. So the diagonal elements are responsible for scaling. So similarly here also A, E and I are the 3 factors which are scaling factor along x. So A is nothing but Sx, E is nothing but Sy, and I is nothing but Sz, scaling factor along Z. So Sx, Sy and Sz in case of 3-dimensional. and the off diagonal elements B and C are responsible for shearing. So similarly here also, these off diagonal elements BCF and DGH, they are responsible for shearing effect. Okay, all of you are getting this, and this is nothing but your overall scaling factor H. This is always 0 because these are used in case of projection. That part has been removed from your syllabus. Earlier it was there, before 4 or 5 years it was there, but now this portion is removed, and that's why these three elements are always 0. Okay, so that is the relation between 2D and 3D. So 3D translation. So in 3D translation, already we have discussed this Tx, Ty, Tz are responsible for translation along XYZ direction. All elements are identity matrix like that. So you will be getting X dash, Y dash, Z dash if I'm multiplying XYZ with this T matrix. Okay, so that is about 3D translation. So you can see here, the object was placed here, that has been shifted to a new location where X dash is X plus Tx, Y dash is Y plus Ty, and Z dash is Z plus Tz. So as in case of 2D, the 3D means only Z coordinate has been introduced, and for Z translation we have the other factor Tz into existence. Okay, so it is again the linear movement of the object. Next is 3D rotation. So 3D rotation. So rotation is carried out about the specific axis. So earlier the rotation was carried out with respect to origin in case of two-dimensional objects. But here in case of 3D rotation, it is carried out with respect to axis. So three kind of rotations are there: rotation about x-axis, rotation about y-axis, and rotation about z-axis. So three axes are there. Out of that, x and z rotations are considered as positive, and y direction rotation is considered as negative. Y direction rotation is considered as negative. So let us see why it is so. Why it is so. So see here, x-axis rotation. X-axis rotation, it is shown here. Now, whenever the rotation about any axis is carried out, then that particular coordinate remains constant. That means here the rotation is carried out along x-axis, so x will remain constant. Only y and z will be changing. Why it is so? So I will show you one diagram. Consider this is a line which I want to rotate about x-axis. So I am going to revolve this line around x. I am going to revolve this line around x as if our earth is revolving around sun. Whether the distance of earth and sun is changing? No. The distance between earth and sun is same. Similarly, here also, the line is revolving around x. So it may change the y and z values, but the coordinate, this point, is having this much amount of distance from x. It will remain constant throughout the rotation. It is like one, this is your, see, okay. So this is, all of you are able to view this pen and duster.
Yes, ma'am.
Okay. So pen is acting as your x-axis, and now the duster is rotating around x. So when it is rotating around x, the white surface will have a fixed distance from x, and it is maintained throughout. So whenever it is revolving, the distance of white surface is going to remain same throughout the rotation. The distance between white surface and pen, that is x-axis and the object, it is going to remain constant. But at that time, your y is changing. Earlier, it was having the positive y. Now it has changed. It has become negative y. Similarly, it will have change in the z parameter as well. So x is not changing, only y and z are changing. So here it is written, x-axis rotation, x dash and x are same. Y dash and z dash will change in terms of cos and sine, because now it has to do with the angle. आपला 2 dimensionचा T matrix काय होता? Cos and minus sin theta, cos theta. बरोबर? So in 3 dimension, what I will write? X-axis means what? X-axis means first column and first row. X is first column, first row. So if I want to make x dash is equal to x, I will have one multiplying factor, and remaining all things will be 0 because I don't want to add anything into x. I don't want to add anything into x. So remaining all things will be 0. Simply the multiplication factor is equal to 1. And then these things, this is your ty, tz value is already 0. And this is 1 overall scaling factor. These values are already 0 for projection purpose, right? Now what is remaining? Only these 4 spaces are remaining. So those 4 spaces are nothing but your cos theta, sin theta, and cos theta. So I am going to fill those 4 locations by cos theta minus sin theta, and cos theta if anti-clockwise rotation is there. Getting it? Yes. Yes, students.
Yes, ma'am.
Okay. And that is how x dash into this, when I perform the multiplication of this xyz with this, what will happen? 1 into x will be there. Then further zeros will get added into it, because I am having these all things 0. So I will add zeros. X will be multiplied with 1 so that x dash and x will be same. And then y and z will have different values, like cos theta minus sin theta, cos theta. It is the amount by which your y and z will be changing. Getting it? That is rotation about x-axis. Now, what will be the rotation about y-axis? Can anyone tell me? Rotation about y. आता y बरोबर रोटेशन होते म्हटल्यानंतर y कोऑर्डिनेट सेम राहील. सेम आपलं टेक्निक. आता हे this is your y axis. The pen is vertical, so it is y axis. And you are going to rotate it about this pen. And that's why your y value will remain constant. X and z will be changed. Right? So y value means second row, second column. Y value means what? This second row and second column. Then I want y dash is equal to y. So the second row, second column element will be 1. Remaining all will be 0. These are already 0. This is overall scaling factor 1. These two are 0 due to projection. So now I will have only 4 locations which I need to fill, and that is done with the help of cos theta sin theta, these 4 terms. But here we have already discussed that rotation about y is considered as negative. And that's why negative means these two will get interchanged. And that's why I will have the cos of theta here. Here I will have minus sin theta. Here I will have cos theta. And here I will have sin theta. Okay. So this is the T matrix for rotation about y-axis. So just we will see that whether it is correct or not. So y-axis rotation. So you can see here cos theta 0, sin theta 0, then 0, 1, 0, 0, then minus sin theta 0, cos theta 0, 0, 0, 0, 1. Okay. So y dash is equal to y now. And x and z are changing with respect to sin cos thetas. Okay. Now what will happen with z axis? Can anyone tell?
Ma'am, Z become constant and X and Y become changes.
Right, very good. So here I will write that where I should write here. Okay. So this is your matrix for Z rotation. Now Z means third row, third column. So third row, third column, that is 3, 3 will be having value equal to 1. The remaining all will have value equal to 0. These two are already 0 due to translation is not carried out. This is 1 due to overall scaling factor. These two are 0 due to projection. So now again only 4 elements are remaining. And that is written in terms of cos sine. So here Z direction rotation is considered as positive. Only Y is considered as negative. So here cos theta minus sin theta. Here sin theta and cos theta. Okay. So let us see whether our T matrix is correct. Yes. You can see cos theta minus sin theta, cos theta. This is 1, 1. Remaining all elements are 0. Okay. So that is how we can get the rotation for rotation about T. Sorry, rotation about Z mat. T rotation mat about Z. Okay, is it clear?
Yes, ma'am.
Boys side.
Yes, ma'am.
Okay. So let me clear all these things. And we will see the next point, which is scaling. So already I have discussed these diagonal elements are responsible for scaling, where it is Sx, Sy, and Sz. Okay. So in the same manner, if we are going to have Sx, Sy, Sz greater than 1, It means we are expanding the object. This is original object. And if I want to make it double, Sx, Sy, Sz all should be equal to 2. So when it is greater than 1, then expansion takes place. If less than 1, then compression takes place. So that is what is your 3D scaling. Then comes 3D reflection. So what about 2D reflection? 2D reflection is carried out in 4 cases. First is reflection about x, reflection about y, reflection about y equal to x, reflection about y equal to minus x. So all these 4 are the cases with 2D reflection. Similarly, in 3D reflection also, there are 3 cases. One is the reflection about xy plane, reflection about yz plane, and reflection about xz plane. So there are 3 reflection with 3 planes. In short, I will show you the diagram. Consider it is an object, a cube, that I want to perform the reflection about the plane. This is your x, this is y, and this is z. So my question is, if I want to reflect this with xy plane, or before xy plane, let us consider yz plane. I want to reflect this object about yz plane. This is your yz plane, right? Or I will extend it in the other side so that it will be easier for you to understand. Okay. Right? This object is lying on the right hand side of this YZ plane. Right? All of you agree with this?
Yes, ma'am.
Yes. So this is your YZ plane and object is lying on the right hand side towards positive X. Positive X च्या side ला बरोबर. Now after reflection, so this is acting as a wall or this is acting as a mirror. So before reflection, object is on the right hand side. After reflection, it will be present on the left hand side of the wall because this is acting as a mirror. So object is present on the right hand side first. After reflection, it will go here, this side. बरोबर आहे? So it will go beyond the wall. Wallच्या opposite side ला जाईल. What is this face? Can you tell me? हे कोणतं face असेल? The face which is pointing towards the plane. Okay, when mirror is in between and you are having two objects or one object's reflection, that means this particular fingers will be pointing like this. So the face over here, it will be present after reflection to this side. That means the face which is near to the mirror, it will still remain near the mirror on the opposite side. जे face mirror च्या शेजारी होतं. that will still remain near the mirror, but in the opposite side. जे back side ला होतं face, that will remain after reflection also back side. कळतंय? Getting it, all of you? Or
Yes,
shall I
ma'am.
explain it again?
Yes, ma'am.
Girls?
करा परत एकदा.
एक second. I will take the example of this duster again. This is your YZ plane. My hand is acting as a YZ plane, and the object is placed this side towards positive x-axis, suppose. After reflection, this white surface will be present here. म्हणजे व्हाईट सरफेसच एकमेकांना फेस करतात, बरोबर? बिकॉज व्हाईट सरफेस वॉज क्लोजर टू द प्लेन. आफ्टर रिफ्लेक्शन ऑल्सो इट इज स्टिल क्लोजर टू द प्लेन. Getting it?
Yes, ma'am.
Right. So
Yes, ma'am.
I can say now that after reflection, the object is not going to change except its x coordinate. आता हे YZ plane होतं. This was your YZ plane. आधी ऑब्जेक्ट होता तो पॉझिटिव्ह एक्सच्या साईडला होता, आता तो कुठे गेलाय? तो ऑपोजिट डायरेक्शनला गेलाय, वेअर एक्स इज निगेटिव्ह आफ्टर रिफ्लेक्शन. बरोबर आहे? It means the T matrix will have only x value will change in its sign, all other remaining values will be same. मग x ला जर साइन नी चेंज करायचं असेल तर त्याला -1 नी फक्त मल्टिप्लाय करावं लागणार. रिमेनिंग ऑल व्हॅल्यूज विल बी सेम. म्हणजे तिथे काहीच करायची गरज नाही. दॅट विल बी इक्वल टू आयडेंटिटी मॅट्रिक्स ओनली. Okay, that's it. So here, when I am having the reflection about YZ, जेव्हा माझ्याकडे YZ बरोबर रिफ्लेक्शन असतं तेव्हा Y आणि Z will not change, only X will change in its sign. This is the T matrix. Getting? So it is explained in the next slide. I will show that next slide to you. Okay. So now you can better imagine the things. So first object is on positive x-axis. The reflection is taken about YZ plane. Earlier, the object was on the right-hand side. Afterwards, the object is on the left-hand side, so towards negative Z, and that's why negative X. That's why X is changing on its sign. Remaining all things will be similar as it is. Here, what is happening with XY plane? आधी object front side ला होतं. After reflection ते back side ला गेलंय. That means पहिले Z positive होता, आता Z negative असणार. That means Z is only changing because plane is XY. जे नाव असेल प्लेनचे ते कॉन्स्टंट राहतंय, जे नाहीये त्याच्यामध्ये ती व्हॅल्यू मायनस होतीये. दॅट इज द इफेक्ट ऑफ डिफ्लेक्शन. जर YZ प्लेन असेल तर YZ मध्ये काही चेंज नाही झाला, एक्स मायनस झालं फक्त. जर XY असेल तर XY मध्ये काही नाही चेंज झालेला, Z फक्त मायनस झालं. आणि जेव्हा XZ प्लेन असेल, जेव्हा XZ प्लेन असेल, ऑब्जेक्ट इज हियर. After reflection, it will show downwards. It will show here. That is nothing but Y value earlier positive, now it is negative. म्हणजे जेव्हा प्लेन XZ असेल तेव्हा XZ मध्ये काहीच नाही फरक पडला, Y फक्त मायनस झालं. Getting it?
Yes, ma'am.
Right. And this reflection is a combined reflection, which is first reflected along YZ and then along XZ. वाय झेड आणि एक्स झेड बरोबरचं रिफ्लेक्शन म्हणजे दोन्ही चेंज होतात तेवढंच फक्त दाखवायचं. इट्स ओके. सो दॅट इज द रिफ्लेक्शन ओव्हर द प्लेन्स. Getting it? So in 3D reflection, there are three cases: reflection along XZ, Y changes, reflection along YZ, X changes, and reflection along तिसरं जे काय राहिलं असेल ते XY, Z changes. Getting it?
Yes, ma'am.
Okay. So we will stop here for today. Now 3D shearing is remaining. Okay, otherwise we will cover this 3D shearing also. 3D shearing is same as that of 2D shearing. Only you can see the diagonal elements are always one. The off diagonal elements are responsible for shearing. That's it. If you are changing, if you are having the non-zero values here, then shear along Z axis is done. Z म्हणजे काय? जर थर्ड रो मध्ये तुमच्या नॉन झिरो इलेमेंट असतील तर शेअर अलॉंग Z. जर सेकंड रो मध्ये तुमचे नॉन झिरो इलेमेंट्स असतील then it is shear along Y. And if first row contains non-zero elements, then it is shear along x-axis. Only these three things are there in the shearing. So shearing will cause the deformation in the shape of the object. Shearing मुळे काय होईल? The object shape will get distortion in the shape of the object. Getting?
मॅम ह्याचं पण एक्झाम्पल घ्या शेअरिंगचं.
Okay, so that we will see in the next lecture. We will stop here for today. Sharing example we will see in the next lecture. So in the next lecture we will be finishing with the chapter number 3 and then we will start with the chapter number 4. Okay, so these slides will be there. Tomorrow we will be finishing with this. Give attendance. Roll number 1,
प्रेझेंट मॅम.
2,
ma'am.
3, 4.
Present, ma'am.
Roll number 3 is there. Okay, okay. Roll number 4. Not there. Roll number 4. Roll number 5.
प्रेझेंट मॅम.
Roll number 6. Seven, 8,
प्रेझेंट मॅम.
9,
Present, ma'am.
10, 11,
प्रेझेंट मॅम.
12,
प्रेझेंट मॅम.
13,
Present, ma'am.
14, 14, 15.
Present, ma'am.
Okay. So all of you may leave now. We will stop here for today.